is B. Yes, it should be also 1 unit. And your hypotenuse will be under root 2 by applying Pythagoras theorem. That was obvious because we have done it yesterday's class. That was the foundation for building under root 2 on the number line. Let's move forward now. We have applied the Pythagoras theorem too because we need under root 2 here. So that's why we need under root 2 in order to build under root 3 on the number line. Under root 2 is over here and 1 is perpendicular. By just squaring them, and in order to get the hypotenuse, I am getting root 3. You understood the idea? You understood the concept over here I'm applying? I need to get under root 3 on the number line. Yes, so I need to see which two numbers when squared gives you under root 3. And these two numbers are under root 2 and 1. Keep under root 2 your base. Under root 2's square gives you 2. 1 square gives you 1. And taking overall under root 2, the answer will be your under root 3. Just write it down. Just write it down. And you will be observing that under root 2 we have represented on the number line will be taken as base for the under root 3 and perpendicular will be your 1 unit. How are you going to draw it? Should I move forward? Yes. So 1 unit is over here, 1 unit is over here. That was your under root 2. Now this under root 2 will be acting as your base. Fine, this under root 2 is acting your base. Now just keep the center of your protector here to the point B and exactly mark 90° and cut the point at C of 1 unit. Just do it. Under root 2 is our base and align the protector with the existing line here. Yes? And keep the center hole of your protector to the point B. Now mark 90° angle of 1 unit. That will be your perpendicular. Yes, that point C. Just note it down. And these are the construction steps. At point B, top of perpendicular, draw another perpendicular. Yes, that was initial perpendicular. We have represented under root 2. And now under root 2 is our base. We have to get another perpendicular of 1 unit over here. Make sure this line should align on 90° angle. Then only it will be counted as perpendicular. Next step is join point C to O. Next step is join point C to O. That would be your under root 3. But like yesterday, now under root 3 is flying somewhere. We have to pin it down to the number line. How we will manage it? By making an arc. Very good. We have to draw an arc right now. That's how your geometry will look. How are you going to make an arc? Just take your O as center. Open the mouth of your compass to under root 3 or the distance OC, you would say. Just open the mouth of compass to the distance OC and just make an arc over here. Just make an arc. That arc will bring it down to the number line. Let me show you. Keeping center O, opening the radius to OC, drawing an arc will give you the geometry like that. And from point O to that dotted line, your distance would be root 3 units. Isn't it? You got the method? Now let's see the final look of under root 3, how you have drawn it. That is your final look of under root 3 representation. Here O was our center, OC was our radius, and that arc is taken here. That point is taken as under root 3. That was the initial triangle of ours. That was another right angle triangle by taking under root 2 as base, 1 as perpendicular. After joining, we have to mark an arc, and that arc will lead to represent under root 3 over here. Yes? Note it down. You just practice well, you will be getting it. If you have any doubt, you can ask your teacher present there. He or she will help you to draw it, to represent it properly. Now you can see the difference. That was under root 2. The right angle triangle triplets are 1, 1 gives you under root 2. Now putting O as center, taking this as radius, after drawing an arc, you are getting under root 2. But here, the triplets I am using is under root 2 and 1 gives you under root 3. So under root 2, firstly I have to draw under root 2. Then I'll be taking it as base, and somewhere 1 unit will be our perpendicular. Then after joining that O to C, that triangle is that triangle. Now that triangle, keeping O as center, by taking radius as OC, you will mark here that point touched on the number line is represented as under root 3. Now let's just revise it by drawing under root 5. You don't worry, you will get pro at representing irrational numbers on the number line. Here, under root 3 was that non-terminating, non-repeating that we already know it is counted as irrational numbers. What is the real life use? Have you ever noticed the equilateral triangle? It is having the height as, this is the formula of finding the height of an equilateral triangle, that is under root 3 into a by 2. Yes, that we will discuss in some other class, but that was the real life use of under root 3. Now let's just introduce under root 5 in the same way. It is non-terminating, non-repeating, no pattern, hence it is an irrational number. We have to pin it down on the number line 2, like under root 2, like under root 3. The same thing. Now think about the triplets that will give you under root 5. 2 square plus 1 square will give you what? Are you getting under root 5 like this? So what are the triplets we are using? The triplets are 4, 1 and 5. So with the help of 4 and 1, we'll be drawing under root 5. 4 means what? 2 square. 1 means what? 1 square. Yes. So I have to draw firstly 2 units, the horizontal line over here that will be counted as our base. Our base will be of 2 units. Our perpendicular will be of 1 unit. 2 square gives you 4, 1 square gives you 1. That will give you hypotenuse as under root 5 by following the Pythagoras theorem. Let's move forward. Just draw with me horizontal line along with the ruler and the perpendicular with the help of protractor. Keep the center hole of your protractor to the point here and just mark the 90-degree angle exactly to the 1 unit distance. The same way, the same steps we are following. The next thing, that hypotenuse is taken as under root 5. We have drawn under root 5, but it's time to pin it down to the number line. Yes, we have to manage to draw it on the number line, to represent it on the number line. Just note it down. Just note this figure. The steps, the same steps. Triangle OAB is right angled at A. OA is 2. AB as perpendicular is 1. Then OB, by applying Pythagoras theorem, you will be getting under root 5. The steps are same and they are very obvious. If you know how to draw, how to represent, how to construct the construction steps, you will write automatically. Yes? Should I move forward? Now again the same thing, put A as center, open the mouth of your compass to the radius AC and just draw an arc. Yes, that's how we just pin it down to the numbered line. Now this distance from O to under root 5 is your under root 5. That's how you have drawn it to the same figure. Representation of all the figures is almost same except the under root 3, because under root 3 we're having two steps. Firstly, we have to draw under root 2. Then we have to take under root 2 as base, 1 as perpendicular. Then we have to mark, then we have to take another right angle triangle and we have to mark an arc again. That is a bit tricky, but you will get it after you will be practicing. So this is the final look of under root 5. Now, what its decimal representation? Never ending, non-repeating, no pattern, irrational numbers. Remember these values, under root 2, under root 3, and under root 5. So that was our concept for today. Now let's put it into action again. Maths is not just found in textbooks. It's time to think deeply and critically. Are you ready for an activity time? Yes? You can drink water, but be focused. Let's start it. Understand the idea of approximations. Yes, in case of irrational numbers, we are not getting the exact values. So we need to find their exact approximate values. Yes. So here, pi's value is what? Approximate value of pi is 3.14. It keeps on going. It's never ending, non-repeating, but we need to get their approximate values. That should end up to 2 places, 3 places. So we are taking the traditional pi after the digits 2 only, 3.14. And under root 2 is keep on going. We are taking it up to 2 digits after the decimal, 1.41. Either you can take 1.414 maximum. Now under root 5 is 2.23. Did you get the idea of approximation? Yes, these are not the exact values. These are the approximate values we need to find, okay? Now let's combine rational and irrational in order to see the outcomes. Are you excited? Yes? Fine. So under root 2 multiplied by under root 2. That means what? We are squaring of under root 2? Yes. We are squaring of under root 2. Square got cancelled by square root. The answer is our 2. That means what? 2 rational. Means 2 irrational numbers when multiplied gave you rational. Here, pi plus 1. If you are adding a mysterious quantity to some exact quantity, the answer would be what? The answer would also be the mysterious one. Because if you are adding something we do not predict about anything, you are adding it to some specific quantity, but you are adding it into it. Now the whole has become unpredictable quantity. So our answer would be irrational number. When something is added to a rational number, the result will give you an irrational number too. Yes? Now, what if? What if you construct a right triangle with both legs of length under root 2, Both legs means what? The base is under root 2. The perpendicular is under root 2. What is the length of the hypotenuse? Is the hypotenuse rational or irrational? You don't have to think over it. You just have to apply it. Just apply the Pythagoras theorem. You will be getting your answer. Just do it quickly. Base is under root 2. Perpendicular is under root 2. Just find the hypotenuse. How are you going to do that? Well, exactly. You have to square them. Yes, that would be your hypotenuse square. This is the Pythagoras theorem. Now square got cancelled by square root. The answer is 2 plus 2 is 4. But that is your hypotenuse square. We need to get the value of hypotenuse. That square would be turned to square root. And you know that under root 4 gives you 2 as its exact value. It's a perfect square. So answer is 2. Isn't it? Do you need to note it down? Just quickly note it down. Well, right. Let's move further. Design your own construction method for under root 6. First thing that you need to find the triplets. Find the doublets that will make a triplet. Yes? Then where we can apply Pythagoras theorem in. So what combination will you use and how? Out of under root 2, 3 and 5. Are you going to use them? What would be the doublets to give your under root 6 as hypotenuse? Let's see. Under root 3 and under root 3 as two legs. Why? Because under root 3 square, 3. Under root 3 square as perpendicular, 3. 3 plus 3 gives you 6 and taking square root of it gives the value of hypotenuse as root 6. Just note it down. Just have a look over here. Hypotenuse would be what? Root 3 square, root 3 square. Square got cancelled by square root. Overall is square root gives you under root 6. Just note it down. Just feel the question, see the answer, you will get the idea. Interested? Yes. An architect designs a square garden with a diagonal path cutting across it. See, directly or indirectly, we are just talking about right angle triangle. We are just talking about applying Pythagoras theorem. So here each side of the garden is 10 meter. Both the legs are of 10 meter. What is the exact and approximate length of the diagonal? Diagonal means our hypotenuse. What would be the exact if you can find? Means that is your rational number. If approximation is concerned, then it means it is irrational number. So diagonal would be what? Two legs are 10 square plus 10 square. 10, 100 plus 100. Isn't it? 200 and we have to take it as square root, as whole. That would give you 200 means what? 100 multiplied by 2. And as you know that 100 is a perfect square. So its value would be 10 and 2 would be taken as under root 2. The thing is, we are applying under root over here. And these two numbers are in multiplication. That means 100 is also under root and 2 is also under root. And you know that 100 is a perfect square. Now 100's value is 10 and under root 2 would be kept as same. So 10 under root 2 would be your approximate value because we cannot predict the under root 2's exact value. So did you enjoy today's session? Yes, but you don't have to get up. The last 10 minutes are hijacked by your amazing mentor present over there. So enjoy studying. See you tomorrow.